Okay, thank you so much. I'm going to release you very soon. So my pride doesn't allow me to release you until I finish this. I want to draw conclusion to this tonight so that you can make use of the recordings. I don't know. Are you able to see what's happening? Okay. This is the formula. It says the expected value for a particular row and a particular column is given by the total for that row and the total for that column. You divide by the sample size. So let us check. For this one, we are here. And this is what? It's the expected value for its row 1, column 1 equals. So what is the total?
For column 1. Total for what?
I can't hear you.
Total for column 1. Total for.
Yes. Remember, it's column 1 because we are saying here this column is not that important. It's important, of course, because it gives us the names of the variables we are dealing with. Ne? So it's an undergraduate degree, and then it's BA and BBA other. So this one is just there. It's more like a column for labels. So it's not that important. It's not that significant. Same applies to these ones here. This row, these things that you see here are the MBA measures. So we cannot regard this as what? As a row. We cannot call this entire thing as a row. So it's a row, of course, but not significant for this study. So rows and columns are where you see these values here. Only these values here. These are the rows and the columns we are talking about. Are we together? Not the totals.
Yes.
Not the undergraduate degree, not the accounting, blah, this, blah, that. We are talking about these values here. But you know that 31 is what is BA intersection accounting. That is what you know. You have to know. Do you now understand?
Yes.
Yes. So we have the expected value for row 1 and column 1. So this 31 is in row 1, column 1. And then remember the formula says we take the column total, or you say the row total, multiplication is commutative, multiplied by the row total.
The row total.
Yes, you divide by
N.
Yes.
N.
Yes. What is the column total for this 31? This 31, the total for this column is what?
61.
61.
61. You multiply by, what is the row total?
60.
60 over the value of N?
152.
Good.
152.
What is the answer? Rounded off to 4 decimal places?
24,078.
24.08
78.
78.
Yes.
Okay. And then, do you understand?
Yes.
Can we now calculate for this one? This one is
Yes.
the expected value for row, is row number? It's row number?
Row number 3.
Really? This is row number
Yeah.
1. This is row number?
Oh,
Yes, it's row
2.
number 2, column number?
Column 3.
Column number 3 equals. And then what is the total for this row? This row where
31.
7 is located, so it's 31. And then the total for this column where 7 is located?
47.
47. You multiply 31 by 47, you divide by 152. What is the answer?
9,5855.
9.5855. Thank you. Now let's check. These are the values. 7 is associated with 9.5855, which is the same as 9.59. No, I'm tired. Pella, I'm changing positions over and over again. And then 31 is associated with what? With 24.0878, which is the same as 24.09. So let me quickly go to that table of theirs where they have calculated everything for us. Did we get the same answer as theirs for 31?
Yes.
Yes. For 7, it's also the same. Do you see?
Yes.
Yeah. So same thing will apply for all of this. If you are working with 8 here, you know, you take the total in this row, you multiply by the total in this column, and then after that you divide by n, you will get 12.44. Even here, you will do the same to get this one. Should I skip this one? Do you understand?
Yes.
Okay. I take it that all of you understand. So you are going to have this. Look at this. According to that formula, imagine you are supposed to have these things up to 12. So we are supposed to see 31, my what? Oh, you are still calculating the expected frequencies. Then after finding those expected frequencies, you go back to that formula again of chi-square, which is Fi minus expected frequency all squared over the expected frequency. Meaning that in this case, you will always take this with its associated expected frequency, you close them inside the bracket, you square, you divide by this expected frequency. Plus, you can come to this one, you do the same. 8 minus 12.44, you put them in bracket, you square, you divide by the expected frequency, which is 12.44. Plus, you see, you come to this one, just like that. Until you come to this one, you go to this one, up until this last one here. 7 minus 6.80, which is this, you square it, you divide by 6.80. At the end, you will get 14.70. I don't know if you follow what has been done there. Do you understand?
Yes.
Okay. Any question? So they got 14.70 after adding all of this. So you are going to do for each one of them, and then you add, you are going to get 14.70. Are we still together?
Yes.
Okay. So I am going to skip this one. Their answer is 14.70. I think you will be able to take it from here because you have calculated your chi-square. This is your chi-square, right? But let me not assume you'll be able to do it and go to step 4. Remember what we were doing was step 3, where we were computing chi-square. And you are saying you understand, right? We are going to step 4. Can I move on to step 4?
Yes.
Okay. On step 4, remember the formula for finding the critical value for that for that technique, which is the contingency table. We said we are using this formula here. Forget about the other two that you see on top there. I think it was a mistake. So this is what you know. Now, your alpha is 0.05, we know. What about the degree of freedom? The degree of freedom, I said it will be given by R minus 1 multiplied by C minus 1. And then they are telling us that the rows are 4 minus 1. Why are we subtracting 1? It's not that important though, but for interest's sake, we are subtracting 1 because we are dealing with one parameter. So let me explain why they are saying the rows are 4 and the columns are 3. Let us go back. It does not want to go back. So let me erase this for now. So what we know is that 4 minus 1, I will show you how they arrived at 4. 4 minus 1 is 3. And then 3 minus 1 is 2. So at the end, you will have 6 as your degree of freedom. So where you see R minus 1, C minus 1, you will put 6. That is why we have 6 here. So you go to, let me erase here and escape this. Why is it still presenting this? I said this. And then it's 6 and 0.05, remember? 6. We are here. What is the value? 6 and 0.05. What is the critical value? What is the critical value of the intersection of 6 and 0.05?
12,592.
Good, it's correct. So this is your 6, and then this is your 0.05. They intersect at 12.592, which is the same answer as 12.592. This is the answer. Do you see it? Now let me go back to and show you how they arrived at 4 as the number of rows and that as the number of columns. You can check. These are the rows. Do you see them? I said we focus on these numbers, on these ones. How many rows are there? It's row number 1, row number 2, row number 3, and row number 4. Do you see? So that is how they arrived at 4. Don't include these ones. Don't include these other rows. We say 1 because other students would say 1, 2, 3, 4, 5, 6, 7, and then it's gonna be wrong. We focus on these ones that capture the values, are observations. And then the columns, you count them this way. You still stick to the numbers. Column 1, column 2, and then column 3. So 3 columns and 4 rows. You see 4 rows and 3 columns. and what we got. Do you understand now?
Yes.
Okay. I think you can take it further here. What are we going to do to our hypothesis? You have already seen the answer. Ne? We are going to reject it because step 3 is greater than step 2. I mean, step 3 is greater than step 4. Remember, step 3 we
Yes.
got 14.70.
14.
Yes.
Yes.
So this 14 is greater than 12.592. Even if you can draw the graph, you will find a similar thing. You will find that this 14.70 falls in the rejection region. You reject it. You reject H0, and then you will go with what? With the alternative. So they are saying the alternative is 2. So the alternative is saying what? The undergraduate degree affects the choice of major. Isn't it so?
Yes.
Yes, so you will conclude that way. So we are done with chi-square. I think all you need to do is to focus on practicing more. Where you don't understand, you ask questions. Are we together?
Yes.
Is it difficult?
No.
No, it's not, as long as you know the basics. So before I release you, I want to project something here so that you can assist me to check if you understand. I won't dwell much on this because I also want to take a nap. I just want to present something so that you can help me with identifying the techniques only. Just to check if you were understanding. An economist employed by the Metro Rail Commuter Service is studying the daily commuting patterns of workers into the central business district of Cape Town. A study conducted 5 years ago found that 40% of commuters use trains, 25% used cars, 20% used taxis, and 15% used buses. Right? The Economist's own recent survey of while we are still there, what are we given?
We are given the proportion.
We are given the proportions. How many are they?
Four.
They are 4. So it means that if you are using the letters of alphabet, you'll have PA up to PD, right?
P.
Yes. If you use numbers, you'll have P1 up to P4.
P4.
Yes. So the Economist's own recent survey of 400 randomly selected commuters found that these were for trains, these were for cars, these are the observed. This person has observed that. And what I like is here. You see, they are saying the Economist's own recent survey of 400. This 400 is what?
N, the sample size.
Is the sample size. And let me show you something. I want to present this now. I will come back to that. Stack 012 students. They gave you 8 marks, you see? But let's check for step 012. Where is it? Let me cancel this and see. It was step, I think it's October, November 20. This one. Are you able to see the question paper, the new question paper for step 012?
Yes.
Yes.
I think there is a similar question in here. It's here. You see, an economist employed by the Metro Rail Commuter Service is studying the daily commuting patterns of workers, blah this, blah that, yada this, yada that. And then the question is the same, but the mark allocation is not the same. STEP students are given extra 4 marks, whereas tech students are only given up to 8. But the procedure is going to be the same. It's just that the mark allocation is not the same. That is because STEC 012 students, you are doing statistics as a major, and then STEP 012 are not doing it as a major. So the questions are the same. Let me just continue with this one because they are the same. We have identified this and this. We said they are the values of P. What about these ones?
Those are the observed frequencies.
The observed frequencies. How many are they?
We are given 3, but we can calculate the last one.
Good. I'm interested in calculating the last one. How are we going to calculate it? Let's start FA. If we are saying A denotes those who are using what? Who are using, let's see, those who are using trains. It means that the observed frequency for A will be 135, right? And then the observed for B would be 90. It's 115. The observed for C would be 96. And then the observed frequency for D, we don't know it because it's not given. They just said, and the remainder was traveled by bus. So you'll get a mark for calculating this unknown here. And how are you going to calculate it?
We are going to add the observed frequency of A, B, C.
Good.
And
you know
then
that the sum of frequencies equal to N, right?
N.
Yes. Means that when you add FA with FB
B,
with FC,
C.
yes, with FD, you should always get the value of N, which is 400 in our case. But when you add this and this and this, you don't get 400, meaning that something is missing and it's for this. So you will take this, it's given, this is also given, this is also given. You add all of them together, you get the answer plus FD. At the end, you make your FD the subject of the formula, meaning that you will take this to that side, wherein you are gonna have 400 minus this sum here. And then you will get the observed frequency for the commuters, those who are traveling by bus. Do you all understand?
Yes, the answer is 54.
Okay, yes. So it means that we have 54. Others, if they were not calculating, will just calculate. Can the economist conclude that commuting patterns into the CBD of Cape Town have changed since the study 5 years, since the conduction of the study 5 years ago? Test the 5% significance level. Which technique is this?
Goodness of
fit are we using? The goodness of fit. Why the goodness of fit? Do you all agree that it's the goodness of fit?
Yes, I do.
Okay.
Yes.
Why are we saying it's goodness of fit?
Because of the change.
Good, because we are testing for the change. Or this experiment is multinomial in nature. Why are we saying it's multinomial? Because it has more than 1p. It has more than 2p, I mean to say. So they are 4. 1, 2, 3, and 4. It's a multinomial experiment. So even if they are 3, it's multinomial because they are greater than 2. But if they were 2, it's binomial. I hope we are sorted, right?
Yes.
So let me give you a homework to work on. I'm gonna release you here. I will post the recording Ishi, I can see you are in class. I will pause the recording. You can start playing them.
Yeah, but are you not going to calculate this with us so that I can understand? Because I remember last time I asked you to help me with this one, and you just said, yeah, I'm doing this and that. I'll come back to you, and you never did. So help
Okay.
me
Yeah,
now.
I told those who were in class yesterday that I gave you this question deliberately or intentionally because there was no way you can solve this kind of question without knowing the basics of contingency. I mean to say of chi-square distribution. This is chapter 10. So I wanted to see how you were going to work on this. They also indicated to me that they are struggling with this. They couldn't solve it because it's chapter 10. I wanted to challenge you a bit so that you go and study. You read through chapter 10 and then you solve this. There was another question from stack 012. This one here, I think it was it not question? Let me see. I think it was this question. Yes, it was this one, question 3. I wanted to see what we were gonna do. So this one is chapter 11, regression analysis. You cannot do this if you don't know the basics for regression analysis, unless you have worked on this, right? So I just wanted to challenge you a bit, but I'm going to upload the recordings now so that you can watch what you have missed. You have explained your problem to me, so I will make the recordings available to you. And I said I want to give you a homework, right? Let me see. It's fine. Let me release you so that I can check. I will go through my question papers, or let me open this one and see if I cannot find something. Okay. This side, we don't have what I want. They are going to be too complicated for you. The University of Limpopo encourages. The University of Limpopo is trying to encourage people to stop driving to campus. The university claims that the other year they just gave you free marks here, 10 marks just to do this. That one is simple and it's not chi-square. It's fine. I am releasing you now, and then what I will do, or let me check the last one because I have the last question paper here for 2019. Let me see if I cannot find something. 2019. A city report did this on first 12 midnight. Okay. What they reported, the report provided the following call. For 28 days, there were no calls. For 20 days, there was one call. For 7 days, there were two calls. And for 5 days, there were 3 or more calls each day. Past data show that 49% of the time. What? Past data shows that for 49% of the entire time, there are 2 calls. No, let me not give this one to you. I will give it to stack 012 students. I don't want this because it will confuse you. So here they are supposed to determine whether the investigation fits the prescription of multinomial. So I think they know how. So for you, you don't have to go this far. all you need to do is to calculate, to test for hypothesis. I will find questions for you. Let me release you and then we shall meet again in the next session. Now I'm going to upload the recordings for you so that you can start studying. Thank you so much for attending. Do you have questions or comment to make?
Please don't forget to upload the recordings because you usually upload them late.
I'm going to upload them now before I forget. Thank you so much. Any other thing?
May I please have the stack 012 question paper?
Step.
Stack.
Okay. I will forward all of them to the group.
Thank you.
Yes. Any other thing before I release you?
Is the homework also dedicated to me because now I missed all the sessions?
The homework was?
Like, am I supposed to also write the homework
Yes, isn't it that you
without
are
knowing
going to?
anything?
Yes, you are going to play the recordings now, as per the agreement we had before I conducted the session. So after listening to the
Yeah.
recordings, yes,
Yes.
yes,
Oh, okay.
yes.
No
After listening to
problem.
the
Yeah.
recording, I'm gonna need the homework before midnight today. So it means that you have the whole day to process whatever you are going to listen to now, right?
It's not the whole day.
Eh?
It's not the whole day. Pella, we
Or
have to
half a
study at the
day there. Yeah, but
Yeah.
it's more than enough because the session is gonna take less than 3 hours.
Less than 3 hours.
Yes, it's less than 3 hours. You can play, you can sleep at around 4 and then you do the rest. But you can attend for 1 hour because I think the basics were covered within the first 2 hours, I mean to say. So you can play the first part and the second part, then with the rest are just examples. As long as you understand the basics, you will never go wrong. So it's fine. I will release you for now and then I will send you everything, but I need my homework before midnight. Yes. Thank you so much for attending.
Okay.
Let me not keep you waiting for long. And then, yeah, if you have questions or more additions or subtractions to make, you can text me privately or even in the group. We will address them. Thank you so much. Have a blessed night. Until we meet again on Tuesday, where we are going to, for STEC students, we are going to look at which chapter is it? ANOVA, I think. And then for STEP students, we are going to look at the last chapter for this year, which is regression analysis. Thank you so much. Good night. Good morning.
I will not stress someone. The good night, please.
Bye-bye.